took tens of thousands of years of human progress to invent photography, to discover a way to capture and fix light permanently, to burn an image into a frame and preserve it forever. But once we had discovered one way to do this, we pretty much immediately discovered like 20 more. And not all of these ways of creating a photograph are practical or easy or even useful, really, but I figured that they would be fun to talk about anyways. So today, I am going to explain the unique chemistry and methods behind 7 different photographic processes. 7 completely different ways of creating a photo. There are a ton of these photographic processes that I could have talked about, but I picked the ones that I was personally most interested to learn about. So hopefully you agree with my selections, but let me know in the comments below if I missed one that you were excited to hear about. A big thanks to alternativephotography.com, which has an A to Z list of alternative photographic processes that was really helpful in writing this video. Alternative processes, which is what we're talking about today, otherwise known as alt process, describes any non-traditional process for printing photography. And as you will see, some of these non-traditional processes will get pretty wacky. So with all that said, and without further ado, let's jump right in and talk about alternative process number 1, cyanotype. If you are on the crafty side of Instagram, you have probably seen someone making something with cyanotype. This process was invented in 1842 by Sir John Herschel, who was experimenting with light and its effects on iron compounds. Cyanotype is made up of 2 different iron compounds. It's got ferric ammonium citrate, or ferric ammonium oxalate, both of which are ferric salts, and potassium ferricyanide. When exposed to sunlight, the ferric salt is reduced and combines with the ferricyanide to create ferric ferricyanide, a pigment also known as Prussian blue. So, areas hit by light turn a dark blue, while covered areas do not. If you paint it on a white piece of paper, you get a rich blue and white print. After the print has developed in the sun, you can rinse it with water to remove the sensitive solution from unexposed areas and fix your print permanently. Cyanotype is probably one of the most accessible photographic processes in this video, because you can buy a kit on Amazon for like 20 bucks and get started. You simply mix part A, which is the potassium ferricyanide, with part B, which is the ferric ammonium citrate, and then paint it onto the surface of your choice. You can place a negative on top to print a photograph, or place objects on top to create a photogram. Photogram is a good vocab word. A photogram is a picture produced with photographic materials, but without a camera. It is not the same as a pictogram, and I did have to re-record a section of this video because I kept calling it a pictogram. It's not the same as a pictogram. Photograms can be made with all kinds of objects, but people seem to enjoy using leaves, flowers, and other natural materials, such as algae in these beautiful photograms made by Anna Atkins in the 1800s, shortly after cyanotype was invented. I tried this on multiple occasions, and I somehow washed the print off immediately when I rinsed the solution with water. I did this with my mother-in-law, and she did the exact same thing that I did, except hers worked out, and hers worked out really nice, and now she's got a pillowcase, and I have a blank piece of paper. But we still had a good time, and I'm still gonna do this again someday. I'm working on getting transparencies printed so I can print some photographs this way, so stay tuned for that. Moving on. Photographic process number 2, we have chlorophyll process. And I figured this would be a good companion piece to cyanotype, since cyanotype is so often used to make prints of leaves, and chlorophyll process is a process for making prints on leaves. It is a completely different chemical process though, and it's honestly kind of wild that this one works. Chlorophyll process is an organic photographic process in which sunlight is used to bleach images onto leaves. You see, most plants have a variety of pigments that absorb or release energy depending on how much light the leaf is being exposed to. And these pigments are different colors, right? Because different colors absorb or reflect different amounts of light. You guys know this, you're photographers. A plant's color might tell you a lot about where they live and grow, or the lighting conditions they need to thrive. Or you can ignore all that and read the care tag that comes with your houseplants, which is almost always misleading. Like, I have a vendetta against houseplant care tags. Don't put ice cubes on your orchid. Who came up with this? Listen. If you have a plant question, just ask it in the comments down below and I will answer. Don't listen to the care tag. You know what? Anyway. If you like keeping houseplants, you'll see that certain houseplants will change color when lighting conditions change. Like, you buy a fancy colorful succulent and then like 2 weeks later it's green. That's because it's not getting enough light. It's changing its color to moderate the amount of light that it's able to absorb. Green chlorophyll pigments are the most abundant in almost all plants, and so they appear green. But when you hit them with a ton of light, those pigments can break down, and so different pigments have to step in to intervene and salvage the photosynthetic capabilities of the plant. The plant will replace chlorophyll with carotenoid pigments. These are yellow or orange. So, grab a philodendron leaf and lay a positive transparency on top, and then leave it out in the bright sun. The sun will bleach the uncovered areas, and covered areas will remain green. Unfortunately, the leaf will eventually die and dry out completely, at which point the print will disappear unless you take steps to preserve it. So, chlorophyll printmakers will dip leaves in resin to trap in moisture and preserve the pigments. Some folks also recommend soaking it in slightly alkaline water by adding a pinch of baking soda, and this is part of a really complicated chemical process that I don't have time to fully explain, but you can read about it on alternativephotography.com, and I'll link it in the description below, so you can go and check it out if you're interested in trying this. Chlorophyll printing is closely related to anthotype photography, which happens to be number 3 on my list. Anthotypes are images created using the photosensitive material from plants, just like chlorophyll prints. It makes sense, right? Like, we have these creatures all around us that are naturally photosensitive. Of course they're useful in photography, an art which relies on photosensitive materials. Y'all are doing too much with ferrocyanide and silver nitrite and all that crap. We got everything we need right here. With anthotypes, the print is not made directly on the leaf as it is with chlorophyll prints. Rather, a solution is made of crushed flower petals, fruits, vegetables, and other photosensitive plant materials, and then it is painted onto a sheet of paper. You gotta dry this emulsion in a dark environment, and then you're ready to print. You can place a photopositive onto the sheet to make a print, or place objects on top to make a photogram. And just like cyanotype, you then leave it in the sun. It only takes about 2 hours on a bright summer day to bleach away the dyes in the plant material that are hit by sun. And the prints look really pretty, like beautiful, soft pastel colors, unless you use turmeric, in which case it's a pretty bright yellow. You can make anthotype with a ton of different organic materials, including turmeric, cherry juice, beet juice, pretty much any dye-rich plant. This process was also pioneered by Sir John Herschel, the same guy who invented cyanotype. And it turns out that this guy had his hands in so many buckets. Like, he invented 3 different photographic processes, but he also named 7 of Saturn's moons, investigated colorblindness and astigmatism, inspired Charles Darwin with his writings on the study of natural philosophy, and discovered 3 new galaxies. So this guy gets around. Sir John Herschel discovered anthotype in 1839. This is a big year for photography. And Mary Somerville, a fellow polymath and scientific researcher, built on his findings and documented her research in a letter to him in 1845. Since then, researchers have experimented with optimal combinations of plant materials and additives like baking soda and isopropanol to create the most vivid, long-lasting prints possible. Now, as a professional photographer, I am well aware of this process of experimentation. Not with isopropanol and baking soda necessarily, but I do my fair share of trying out new methods, workflows, and tools to optimize my results. Which is why I am happy to share today's sponsor, PicDrop. PicDrop is an easy-to-use photo sharing platform for photographers. It is built by photographers for photographers, and it has really changed my workflow for the better. PicDrop makes it easy to share photo galleries with clients and get client feedback. Your clients can download, select, and comment on their favorite shots, and it lets you know which shots have been downloaded, so you can keep track of which shots clients actually liked best. I have been really satisfied using PicDrop, like, honestly. Before this, I was just using Google Drive to share photos, and obviously that is not ideal. I don't know why I did it for so long. PicDrop lays out your photos in an appealing gallery, showing each photo in its entirety and not just thumbnails. You can select the size that you want your photos to appear and curate the presentation of your photos with a variety of sorting and grouping options. Before you send out your gallery, you can preview it to make sure that everything is just right when you deliver it to your client. And I cannot emphasize enough how nice it is to have client feedback tools built right into the gallery. We got color tags, annotations, comments, and scribbles. There's no more going back and forth with clients on Instagram DMs, getting screenshots of their favorite photos without file names attached, and I don't know, I put up with a lot of nonsense using Google Drive for as long as I did, and now that I'm free of it, I am not going back. If all of this sounds good to you, then you're in luck, because you can get 2 months for free by clicking the link in the description below. Click on that link, or use promo code YHansen when you sign up to get started with PicDrop today. Okay, moving on from plants and plant material and Sir John Herschel and all that, we have got something completely different here. Here's number 4, carbon process. This was invented by Alphonse Poivatin in 1855. This process originally used lamp black, which is basically carbon dust, to create a black and white image. The process was later adapted by Louis Duclos de Haron in 1868 to include colored pigments, which allowed for the production of colored prints. And this process of creating colored prints remained popular throughout the first half of the 20th century. But how does it work? Okay, so a carbon print is made by coating a sheet of paper with a mixture of gelatin and pigment. The sheet is called a carbon tissue, and it is then bathed in a sensitizing solution of potassium dichromate. Potassium dichromate is a chromate salt. We love our salts in photographic processes, don't we? It contains chromium-4, which is highly reactive, and when exposed to light, the chromium-4 is reduced to chromium-3, which acts as a cross-linking agent in the gelatin. Essentially, chromium-3 links strands of gelatin together, causing the gelatin to harden and become insoluble in water. However, of course, this hardening only occurs in areas where the chromium-4 was reduced to chromium-3 by sunlight, i.e., just in areas that are hit by light. The unhardened areas can then be washed away with water, leaving behind a black print made of hardened gelatin. Y'all have no idea how much science I had to read to understand this process. And I better not have any chemists in the comment section telling me that I got it wrong, because I'm finally at a point where I feel like I understand how it works. I broke it down very simply for you, by the way. Articles online do not break it down this simply, you're welcome. Anyway, to make a color print this way, you need to take the same photo 3 times. Once through a red filter, once through a green filter, and once through a blue filter. You know, like trichromy style. You then make 3 carbon tissues with 3 different colored pigments: cyan, magenta, and yellow, respectively. It's still called a carbon tissue even if you're not using carbon black, and when you mix it in with these colored dyes, you wouldn't be using black, still called a carbon tissue. Anyway, once these layers are exposed and washed, you then layer the images on top of each other to make a color print, starting with yellow, then magenta, then cyan on top. It seems like a lot of work, right? And it is, but the end result looks really good, and for a long time, this was the most viable method of creating color prints. So it is really inconvenient, and that's probably why we don't have a ton of color photography from the first decades of the 20th century, but they made do with what they had. Number 5, we have Van Dyke Brown prints. If you have ever followed along with a Bob Ross painting, you will be familiar with this color. Van Dyke Brown is this deep, rich, warm brown color that's ideal for painting happy little trees. This color was originally made with soil or peat, but today it's made by combining black pigment with iron oxide. It's named after the painter Anthony Van Dyck, who used this color frequently in his works. This printing process does not use Van Dyke Brown pigments, as I thought it did, but the resulting prints are a similar color, hence the name. And apparently, there are a confusing number of different brown tones that have been dubbed Van Dyke Brown throughout the years. So much so that I think now it is just a fancy word for brown in general. But Van Dyke Brown printing, like Van Dyke Brown paint, also contains iron-rich compounds. The printing process is also called iron-silver printing because it uses a combination of ferric ammonium citrate, you'll recall that this was a key ingredient in cyanotype as well, silver nitrate, and tartaric acid. So mix these ingredients together to make your sensitizer solution. Apply these ingredients to a sheet of cotton or paper, expose it to light, and then fix it in sodium thiosulfite, aka hypo, to remove any remaining unexposed silver nitrate. The chemistry behind this is relatively simple. Ferric ammonium citrate is a light-sensitive iron 3 compound, and when it is exposed to light, these molecules are reduced to ferrous ions. These new ions are reducing agents, and they reduce the silver ions in the silver nitrate down to metallic silver. This results in the formation of metallic silver in areas that are hit by light. And that is the end result of pretty much all photographic processes that involve silver. On paper, these silver ions appear brown. Specifically, Van Dyke Brown, apparently. Pretty simple, and probably one of the most popular alternative processes used today. This one is up there with cyanotype in terms of accessibility and simplicity, and the results are really stunning if you get your exposure right. Number 6, wet plate collodion. All of those guys you see on YouTube who mess around in a portable darkroom for like 20 minutes just to take one really basic photo of a tree, they are doing wet plate collodion. If 35mm is like Charmander, wet plate collodion is Charizard. It's the final evolution of a film bro. And I know I'm razzing these photographers a bit, but it's only out of jealousy, okay? I want to take mediocre photos of trees in infinitely high resolution so bad. This process requires the photographic material to be coated, sensitized, exposed, and developed all within the span of about 15 minutes, because the material must stay wet throughout the photography experience. This means that if you're taking photos of the great outdoors, you're gonna need a portable darkroom. You can take photos when the plate is dry, but the exposure time goes way up to like half an hour, making it impractical for on-the-fly photography. This process can be done with a glass plate, but it has also been done with tin plates, and you may know these as tin types. They were very popular in the 1800s, and many still survive today. So, how does it work? Wet plate collodion process involves silver nitrate, which is useful in many photographic processes, reacting with a halide salt like potassium iodide or zinc bromide. First, you're going to create the collodion emulsion. Collodion is a solution of nitrocellulose dissolved in a mix of ether and alcohol. It creates a transparent film when it dries, which binds the chemicals to a glass or metal plate. You gotta mix the collodion with a soluble halide salt. And then, while this mixture is still wet, you dip it into a bath of silver nitrate. And this kickstarts a chemical reaction. The potassium iodide ions in the collodion react with the silver nitrate, producing silver iodide, a silver halide, and potassium nitrate. And now that we've got a silver halide in the equation, we're in territory that many of you may be familiar with, a silver halide reacting with light. When you expose the plate to light, the silver halide molecules undergo photoreduction, becoming metallic silver, which creates a latent image of metallic silver atoms on the plate. Once you have this latent image, you can develop the image in a chemical reducing agent of ferrous sulfate for about 15 seconds. And that brings us to the final installment in today's video. I have number 7, Daguerreotype. Last but not least, we gotta talk about Daguerre, right? Louis Daguerre. Daguerre! The first publicly available photographic process introduced in 1839 by Louis Daguerre, the daguerreotype was a relatively short-lived but effective method of producing a photograph. It works, okay, but the ISO rating of a daguerreotype is around 0.0004 ISO, meaning the necessary exposure times to actually get an image out of this method were kind of ridiculous. I am currently trying out like 5 different ultra low ISO films for a future video, and even ISO 8 is stupid to work with. So I can imagine how slow it would be to work with ISO 0.0004. Daguerre's process requires a sheet of copper plated in silver and polished to a mirror-like finish. The polished silver is then exposed to iodine vapor, which reacts with the silver to form a layer of silver iodide. We love silver iodide. This sensitized plate is then placed in a camera and exposed to light. And when light hits the silver iodide, it reduces to metallic silver and iodine, creating a latent image of metallic silver. The image can then be developed with mercury vapor, which sounds terrible. And the mercury condenses on the particles of metallic silver and creates a whitish looking mercury-silver amalgam, which forms the highlights of the image. You can then fix the image in a sodium chloride bath, aka table salt, and then thoroughly rinse it in water to get your picture. Later editions improved this process by toning/gilding the image with a gold chloride solution. And when you tone the image with gold chloride, the gold ions replace some of the silver and mercury ions in the image, and it forms a thin layer of metallic gold that improves contrast and helps to bind the mercury-silver amalgam to the plate. A vocab word here, amalgams, I had to look this one up. They are alloys formed by mixing mercury with one or more metals, and in this case, it's silver. This process, the daguerreotype, was popular from the 1840s to around 1856 when it was replaced by the collodion process, which was less expensive, faster, and created better looking images, and also didn't involve mercury vapor. Nevertheless, the daguerreotype is an important piece of the history of photography. It was not the first photographic process ever invented, but it was the first one to ever be shared with the world. And that is a pretty big deal. So thanks, Daguerre. Louis Daguerre. That is all for today's video. Thank you all so much for watching. Can I just say, okay, the research for this video was really annoying because there are so many websites that talk about these photographic processes as though they are magic. They use terms like, the plate is then sensitized with sensitizing fumes, or the image is then developed with developing chemicals. That is not helpful, okay? What are the sensitizing fumes? I should not have to go to a different website to figure out what sensitizing fumes are being used. If you're telling me that they're using sensitizing fumes, just tell me what the sensitizing fumes are. You can't just wave your hand and be like, ah yes, the image-making compounds made the image. That's not science, that doesn't tell me anything. Why is it so hard to get information on the chemistry? I should not have to do like 5 different sources to find out. I apologize if any of the chemistry in this video is incorrect or incomplete. I really did my best to be as accurate as possible with it and to answer any possible questions with my explanations. I am not a chemist, but I am like interested in how the material world works. And I actually think like once you break these things down, it's not that hard to understand. But if you just treat it like it's magic, then yeah, it makes it really hard to understand, and it makes it like not as approachable to people who might actually want to try these processes. I think it just sounds complicated when you use terms like sensitizing solution and developer chemicals instead of actually talking about the chemicals that are being used and why. You know what I mean, right? You know what I'm talking about? Probably not articulating as well as I possibly could. It's really hot in here. I don't know if you can tell by the fact that I'm bright red and shiny. Hopefully you found this video interesting. Hopefully you're inspired to try out some of these weird ways of making photographs at home. I know I am. I'm definitely gonna try a few of them. I'm gonna make a video where I test out some of the more accessible methods that I discussed, so stay tuned for that. I'd like to give another huge thank you to PicDrop for sponsoring today's video. Don't forget to check them out in the description below. I will see you all in a few weeks, and in the meantime, I want you all to stay sharp and don't forget to keep taking pictures. Bye guys.